In the last class, we were studying about uh, designing of fermenters, wherein you saw how a fermenter can be designed, how agitators, which helps in mixing of media, can be designed, and how to design a sparger that supplies air into the medium, and how to do temperature control. In next topic will be sterilization of fermenters, which is part of our unit 3. Uh, we have to study about how to sterilize the fermenters and what is the need for sterilization of fermenters. As you know, in microbiological terms, contamination is a huge problem. If that too in large scale fermentation, if contamination is allowed to happen, it will lead to a serious problem wherein the entire yield of the organism will be lost. So we have to see that contamination doesn't happen. For that, the entire process should be in a sterile condition. So first of all, the fermenter should be sterile. Such a huge fermenters also should be in a sterile condition. Every nook and corner of the fermenter should be sterile. Media should be in a sterile condition. Though you are using 10,000 liters of media, for example, that entire media also should be in a sterile form. Next, air supply. Most of the fermentation in industries are aerobic fermentation. That the air also should be in a sterile condition for fermentation to happen. So we will see these three process in detail. First is fermenter sterilization. So as I told you, contamination is a serious problem. Such a huge fermenter, how to sterilize them is a huge question. So we employ steam here. Steam, you all know that it has a high penetrative power and it can flow from one point to another point. So what you do here is you develop steam, and through pipelines you supply the steam into the fermenter. So by this what happens is the steam, because of its high penetrative power, it will enter into the fermenter, every nook and corner, and it will do sterilization of the fermenter. So this moist heat concept is used for sterilization. Steam will be introduced into the fermenter coils. So there are so many pipelines, using those pipelines we will introduce steam into the fermenter. You can even introduce steam through the outer jacket of the fermenter, which is used for temperature control. Through this outer jacket, if you supply steam, that also can lead to sterilization of fermenters. What has to be kept in mind is that the entire entry and exit point also should be kept sterile. See, I've shown you already the diagram of fermenters. In industry, because of automated process, so many pipelines are there. So much pipelines goes in and out of the fermenter. All those pipelines also have to be kept sterile. So you have to devise a technique of how to sterilize the entire pipelines that connects the fermenter and also the fermenter. So lots of work has to be done for steam sterilization. So as given in the PPT, all exit and entry point into the fermenter should be sterilized. And the very important thing is, after sterilization, that the steam should not stay back. Even if they stay back, they will condense. And this condensation also can lead to contamination. So you have to develop your pipelines in such a way that they are slightly slanting, so that nowhere water droplets gets settled. And final point, you can see sealing places. Sealing points are there. Sealing points are the points where the sparger enters into the fermenter, and the place where agitator enters into the fermenter. There seal and welding you would have done. Those points also have to be sterilized. There also contamination may happen. And valves, so many valves will be there to open and close the pipelines. Those valves also should be sterilized. So fermenter sterilization is a important topic, and we have to do a lot of planning so that every nook and corner of the fermenter is sterilized. In the diagram you can see there are three images of how to sterilize a fermenter. The left hand side image, you can see that we do electrical heating. It is something like our hot air oven, dry heat. So that also can be employed for sterilization of the fermenter. Middle image, you can see that steam will be sparged inside the fermenter. So here it is something like our air sparger. Air will be through the small perforated holes, air will be forced into the fermenter. Same way steam can be forced, that is called sparging. We call it as direct steam sparging. So like a jet, the steam will enter into the fermenter and it will sterilize the entire fermenter. The left hand side, the right hand side corner diagram, you can see it is called as steam heating. So steam will be, you can see the arrow mark, steam will enter through the outer jacket and it will sterilize the entire fermenter and it will go. So it will enter and exit points are there, through that the entire fermenter will be sterilized. So these are some of the methods of sterilizing the fermenter. Next, air sterilization. As I told you, air is a very important component for aerobic fermentation. So air has to be continuously supplied during fermentation process, but just you can't take air and supply. Air contains, you all know, air contains so much of microorganisms. You have to first sterilize the air before supplying it into the fermenter. There are different ways of air sterilization as given in the PPT. First is heat or steam sterilization. Next is filtration using various filters, millipore filters or some filters. You can filter the air and supply. UV light, it is also very good in sterilizing the air. And next is chemical agents. So out of these four, if you see, the most adapted is first two techniques, that is steam sterilization and filter sterilization are most preferred for air sterilization. So in this diagram you can see a fermenter is there in the corner, the huge fermenter, cylindrical fermenter. Your goal is to supply air into the fermenter. Right hand side, left hand side corner, you can see air is written as air and arrow mark is there. Through that pipeline you have to supply air into the fermenter. But that entire pipeline should be sterile before you supply air. For that, what we do is, you can see in the top there are so many valves are written as C. Valve means which can be opened and closed. Valve B is there, valve C is there, valve A is there. So this valve C, if you open it, what will happen? Steam will enter. Arrow mark, you can see steam will enter into the pipeline, and you can see one small cylindrical structure. What it is? It is a small chamber through which air will pass into through the fermenter to the fermenter. And you can see this chamber contains filters. That is most important. Filter means, you all know, it is something like our millipore filters, through which air will be filtered and only sterile air can pass. But this filter also should be autoclaved. See, when you do practicals, even the filters will be sterilized. Same way, to sterilize the filters before supply of air, we will open the valve C. Through the valve C, steam will enter inside, and you can see in that small chamber, filter chamber, an arrow mark is written down. That is, the steam will enter through the C into the chamber and it will go out. So continuously, if you keep it open for some time, the filters will be sterilized. Then later, after some time, you can open the valve B. When you open the valve B, what happens? The steam will enter in through those pipelines into the fermenter. So all those pipelines will be sterilized. That is the concept. The concept is steam sterilization of the entire place. Then you can open the valve A. That place also will be sterilized using the steam. After steam sterilization is completed, you close the valve C. When you close the valve C, what will happen? Steam will stop. Now you open the valve A. When you open the valve A, what happens? Air will start flowing through the sterile pipelines, and it will enter into the fermenter. It will get filtered and enter into the fermenter. So this we call it as air sterilization. I hope you have understood. One more example also is there to make you understand still better. In this diagram, only that filter part is shown as highlighted. So air is applied from the top, arrow mark you can see, through the valve A. But first, initially you have to close the valve A and you have to open the valve B. When you open the valve B and C, what happens is steam will enter through B and it will go through C and into that chamber. That chamber contains the filters. You can see porous filter is there, and at the bottom of that chamber you can see D. You have to open the valve D. When you open the valve D, what happens? All the other valves should be closed. Valve E, valve G should be closed. Only B you have to open, C you have to open, and D you have to open, so that the steam passes through this pipeline. It will sterilize the filters and it will flow out through D. Then you close B, you open F. When you open F, what happens? Steam will enter into the outer jacket. It will sterilize the chamber, and you open the G. Through G it will go out. So entry and exit point is F and G. Steam sterilization of the outer jacket. And Now you close B and F entry points. Both entry points are closed after sterilization is done. Now you open A. When you open A, air will pass through that sterile pipelines. It will enter into the filter chamber. It will get filtered. And now you have to, as I told you, close D and G. You have to open E. Only E should be open. So when you are opening A, E should be open, because A valve if you open, air will enter inside. After air is getting filtered, it will go through E, and through E it will, the sterile air will go to the fermenter. So this is how the air sterilization is done in the fermenter. Next is media sterilization. You can just see that there are two things you have to remember, students, here, that media sterilization can be done separately. The sterile media can be supplied to the fermenter. After media sterilization, it can be supplied to the fermenter. Or second option is there. Please listen carefully. You can put media into the fermenter, and the fermenter and media together you can sterilize it. That is what you have studied earlier. Same thing, that is media can be sterilized inside the fermenter itself, or media can be sterilized and then put into a sterile fermenter. Any one method can be followed. Both are good, you can follow. In the diagram here, what you can see here is media is sterilized outside, then it is applied to a sterile fermenter. That is what is shown here. But as I told you, you can do any one. You can sterilize media with fermenter itself. So in this diagram you can see there is a steam injector point. Just observe in the diagram. Both diagrams are almost same. They just show how media is sterilized. So you can see that the steam is injected through a valve, and there is a series of coils you can see. That is called as holding section, where through which the steam is supplied to a cooling point, and then it will enter into the heat exchanger. So you can see where the media is entering. The raw media means unsterile media enters through the a point wherein steam comes in contact. Here at this point only the media will get sterilized, and the sterile medium will enter into the fermenter. So concept is very simple, students. The media should pass through a chamber wherein it is at high temperature, so that the media gets sterile and it will enter. So media will be coming through a pipeline. So you should it is very, see, it is not so easy as you have seen the diagram. You have to adjust the flow rate of the medium. How much of liters of medium will pass per minute. So the holding time is there. See, for example, 1 liter of media will enter into the holding chamber, and it has to stay there for a few minutes, so that 1 liter gets sterilized properly, autoclaved properly, and then it should enter into the fermenter. So that point where the media enters is autoclaving point, we call it as. High temperature will be there, so media will get sterilized and it will enter into the fermenter. So this is the concept used for media sterilization. So the heat exchanger's function is that continuously the steam will be coming in contact, so the heat will be transferred from the steam. The heat will be transferred to media. By this, what happens, the steam will get cooled. So the cooled steam will go back again, and again it will be heated and it will be circulated. So it is a cyclic process. When it heat exchanger, why it is written as heat exchanger is, heat is the heat carried by the steam is given to the media. After that, media will take that heat and media will carry the heat. So that because of that only it is written as heat exchanger. Heat is exchanged between steam and medium. Medium takes the heat and it gets sterilized, and after giving the heat it will go back and it will get heated again and it will come back. So this is how media is sterilized in the fermenter. So with this we complete this PPT, wherein we have studied how media can be, how the entire fermentation can happen in a sterile condition. So we sterilize the media, we sterilize the air supply, and we sterilize even the entire fermenter also, and it is very essential for maintaining aseptic condition.